Hello, everyone, and welcome to this session on quantum computing by Intellipaat. Quantum computing utilizes quantum mechanics to transform traditional computers to better and smarter computers to make unbelievable discoveries in the upcoming years. Quantum computers are needed to solve very complex problems in a short period of time. Quantum computers utilizes quantum bits to encode data as zeros, ones, or both simultaneously, unlike the traditional ones. In this session, you will learn all about quantum computing. So, without further wait, let's start the session. But before we begin the session, make sure to subscribe to our channel and press the bell icon so that you'll never miss any update from us.
Now let us look at the agenda for this video. Firstly, I'll be introducing the term quantum computing. Next, I'll move on to the need for quantum computers in today's world. And moving on, I'll be explaining about three basic concepts of quantum computing. And finally, I'll be giving out the applications of quantum computing in the real world. Introduction. Quantum computing harnesses the phenomena of quantum mechanics to deliver a huge leap forward in computation to solve certain kinds of problems. Quantum computers are machines that enable quantum computing. So, one of the machines is given in the image below, that is the IBM System 1, and they are built on the laws of quantum mechanics. Quantum mechanics is a branch of physics that deals with objects that are really small, isolated, or really cold. Quantum computer is not a more powerful version of our current computers, which are also called as classical computers. Just like a light bulb is not a more powerful candle. You cannot end up with a light bulb by building better and better candles. I mean, you cannot increase the quality of the wax and the wick and end up building a light bulb. A light bulb is a different technology based on a deeper scientific understanding. So, similarly, quantum computer is a new kind of device based on a science of quantum physics. And just like the light bulb transformed the society, quantum computers have the potential to impact so many aspects of our lives. Companies all around the world are working to build quantum computers. The pioneer in this field is IBM, or International Business Machines. Some of the other players include MIT, Google, Microsoft, and Amazon. The diagram below shows the timeline of the companies that are involved in building a quantum computer. Now let us see why do we need quantum computers. Imagine running out of space on your phone while taking pictures. Quite an irritating experience, right? So, just like a phone runs out of space while storing movies or clicking pictures, the fastest supercomputers that we have today run out of space when trying to solve a certain type of problem. Until now, we have relied on supercomputers to solve most of our real world problems. However, supercomputers are not very good at solving certain types of problems, which may seem easy at the first glance. This is why we need quantum computers. Classical computers can do many things, but there are so many things that they cannot do. Let us take a look at one such example of a problem that classical computers struggle to solve. Imagine you want to seat 10 people at a dinner party where there is only one optimal seating plan out of all the different possible combinations. How many different combinations would you have to explore to find the optimal seating arrangement? So, this is a classic seating arrangement problem, and the number of combinations in which two people can be seated around a table is 2. That is, from the image below, you can see the blue guy will sit on the top and the white guy will sit in the bottom, and one more combination is white guy on the top and blue guy on the bottom. So, if you want to seat two people, it is two combinations. And similarly, if you want to seat 5 people, we have 120 combinations. And for 10 people, the number of combinations is more than 3.6 million. So let us see what takeaway we have from this example. Larger versions of these kind of problems, that is the seating arrangement problems, they stump our most powerful supercomputers we have in today's world, and there are reasons for this. So the first reason is supercomputers don't have the working memory to hold 3.6 million combinations of. This is one example of seating arrangements, and similarly they can't hold all the memory of real world problems. that are out there. So, one more takeaway is supercomputers have to analyze each combination one after the other, which can take a long time. This type of problem is called an optimization problem. Another problem that classical computers cannot solve is simulating chemical molecules in the field of chemistry. And in general, we can say that the problems that classical computers cannot solve have something in common. And the common factor is exponential scaling. So, we can say that exponential scaling cannot be handled by our classical computers that we have today. Now, moving on to the concepts of quantum computing. To build a quantum computer, we need three quantum properties, and they are superposition, entanglement, and interference. Let us know about them briefly. Superposition. Just like a classical computer is made up of bits, a quantum computer is made up of qubits. A bit can have two states, that is high, which is 1, or low, represented by 0. Whereas a qubit can have multiple states, and a qubit can exist in all of these states at once. To illustrate this, take a coin. It has a head and a tail face. Here we are assuming head to be high and tails to be low. We can imagine the states of a qubit to be analogous to when the coin is tossed and is spinning. We cannot know the state of a qubit unless it is stopped. The state of the spinning coin is called superposition. More positions mean more combinations and more space to store data of the problem. Now let us see what entanglement is. The word entanglement means two things that are connected in some way, and the modification of one thing affects the other. In case of superposition, we have taken a coin as an example to understand the concept. Now, to explain entanglement along the same lines, imagine two coins to be entangled. When you toss both the coins and measure them, both would measure to be the same. That is, if one coin measured to be head, the other coin would also measure to be a head, and vice versa. Interference. Interference is the situation where intervention from noise in the environment damages the quantum object, in this case a qubit, and also the possibility that the wave functions of particles can either reinforce or diminish each other. We have two types of interference, that is constructive interference and destructive interference. Constructive interference will amplify the signals that are towards the right answer, and destructive interference cancel the signals that are leading to the wrong answer. Now let us see the applications of quantum computing. The exponential growth in computing power that is resulted from a quantum computer will revolutionize a wide range of industries and applications. Let us look at some of them. So, the applications of quantum computing will be affected in the following domains, that is, cybersecurity, healthcare, finance, marketing, meteorology, logistics, just to name a few. Thank you for watching till the end, guys. Have a nice day.
Just a quick info, guys. Intellipaat provides blockchain certification training mentored by industry experts, the course link of which is given in the description below.